Hello everyone, and welcome to my channel. This is an educational channel where we look at a lot of different theories of everything and go into them in depth, let you know how you can benefit from these theories of everything in your own life, helping you with your paradigm shifting, your adaptation to 5D consciousness, your holistic worldview, and your holistic health, mental, physical, spiritual health. And today is our 477th video that we've done on the reciprocal system of theory from Dewey B. Larson. We are taking a look at chapter 9 of his book called Basic Properties of Matter. And chapter 9 is called Electric Currents. So we're just starting this chapter today. In about 1959, Dewey Larson proposed his two fundamental postulates about how he believed the universe operated. And that's just two sentences. And from there, he elaborated those into a theoretical universe. What the universe would look like if his postulates were correct. And then he compared his theoretical universe with the actual empirical, measured, and compiled universe of the legacy scientists. And a lot of the results of that study are written up here in this book, Basic Properties of Matter, which is primarily on chemistry. And we'll take a look at some of his ideas about electric current here. Let's just go through the postulates. The first postulate is basically Larson's own contributions, and then the second postulate is really kind of like more mainstream scientific approach that he uses in order to extend his first postulate to a theoretical universe. So the first postulate is that the universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. And then the second postulate is just that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. And so he takes that first postulate. There's really like 4 prongs of the first postulate. The universe is made out of motion. Motion is the relationship between space and time, which implies a reciprocal relationship between space and time. And space, time, and motion come in 3 dimensions. Space, time, and motion come in discrete units only. Okay, and so he takes those 4 prongs and he runs them through, the universe conforms to the relations of ordinary commutative mathematics. A lot of it is probability, and then its primary magnitudes are absolute and its geometry is Euclidean. A lot of Larson's followers have disputed that second postulate, including me, but I think the main point is that these are just kind of like the ideas that scientists have about how you kind of go about, deducing things. And it's really the first postulate that requires our attention. Now, I have done my first 474 videos on this subject, go over the reciprocal system, how it works in a little bit of detail. I'm going to stop doing that now because I'd like to cover some more ground here with his actual writings. So I'm pretty much going to assume that you have a basic idea of the reciprocal system as we move forward and do some of Larson's own writings on this. I'll try to explain some things in the text that might not be apparent, but really, if you don't know anything about the reciprocal system, I would recommend that you go back and watch one of my first 474 videos on this topic. And I will just say that, just to introduce and to keep going, when Larson is talking about motion, he's referring like a universe made out of motion. He's not the first person to have done that, but I think the first person to like make it work, turn it into a generalized theory, because he defined motion more specifically as the relationship between space and time, the reciprocal relationship between space and time, and that he uses scalar motion rather than vectorial motion as the basis for his building a universe. And so in a universe of motion, we're talking about a scalar motion. That's a motion with a magnitude but no specific direction, which you can envision using a balloon that you put dots on. As you blow up the balloon, all the dots will be moving away from each other. And they won't be moving in any specific direction. They'll just be moving outward away from each other. Every dot will be moving away from every other dot. And so Larson calls that the progression. And if you suck in the balloon and contract it, all the dots will be moving toward each other. Larson refers to that as gravitation. And the key to manifestation is to take that empty universe of the progression, which occurs at all times, in all places, eternally, and to reverse that motion of the progression and turn it into gravitation. That is how you turn motion into matter. And that's done through vibration and rotation. And every atom in Larson's periodic table has 3 numbers. And again, a motion is in 3 dimensions. So it has to be rotated back in 3 dimensions to get from your progression to your gravitation. And so those 3 numbers that Larson uses kind of describe those 3 dimensions. And those numbers are what he uses with his theoretical universe to derive equations for many of the basic properties of matter, such as the specific heat and the thermal expansion and so on. And those are, were covered in earlier chapters of this book. Now we're getting to kind of a different section of this book. We were on chapters on pressure and temperature primarily up until now. And it's also important to note that, okay, why are we doing this? We're looking at kind of in detail about, atomic properties, chemistry. But you have to keep in mind that the reciprocal system is a generalized theory. It's a theory of everything. So whatever you learn about chemistry here, you can apply it to other subjects as well. The same rules that apply to the atom also apply to the galaxy. The reciprocal system is discrete. Everything is in discrete units. There are levels to everything. And on each level, there's kind of like an analogous way of employing the same basic set of concepts. An example is that we just got done with our chapters on thermal expansion, specific heat curves, and these are all kind of giving you the dynamics of the solid state. How these things, when you heat up something, what happens to it up until it gets to the melting point. Well, if you want to go into a metaphysics, you can look at earth, air, fire, and water. Earth, air, fire, and water are, solid. Well, earth is solid. Water is liquid. fire is the vapor state, and air is gas. And so you have to be able to kind of make those analogies. And so if we understand kind of all the details of how the solid state operates, then we can also transfer that understanding to understanding how Earth operates. Earth as an element, as one of the four elements of your, kind of alchemical system. So, we're not just talking about chemistry, we're talking about alchemy. And, these same things could be applied also in economics. So, we're not just trying to specifically learn about chemistry, we're trying to learn principles that can be applied to other subjects as well. Okay, let's start here on chapter 9, electric currents. Another set of properties of matter that we want to consider results from the interaction between matter and one of the subatomic particles, the electron. As pointed out in volume 1, the electron, which he notates as M0, 0, 0, negative 1, in the notation used in this work, is a unique particle. It is the only particle constructed on the material rotational base, M000, a negative vibration, that's a negative photon or a cosmic photon. I guess it wouldn't be a cosmic photon, it would be what you would call a low frequency photon. And positive rotation. Built on the material rotational base, which is a negative vibration and a positive rotation, that has an effective negative rotational displacement. So it's the only particle constructed on the material rotational base that has an effective negative rotational displacement. More than meaning that it's made out of space rather than time. Most of the atom is made out of time, which would be a positive rotational displacement, but the electron is made out of space. Okay, more than 1 unit of negative rotation would exceed the 1 positive rotational unit of the rotational base and would result in a negative value of the total rotation. Such a rotation of the basic negative vibration would be unstable in the material environment for reasons that were explained in the previous discussion. But in the electron, the net total rotation is positive, even though it involves 1 positive and 1 negative unit, as the positive unit is 2-dimensional, while the negative unit is 1-dimensional. Now I believe Bruce Perret, one of Larson's kind of revisers, has had issues with this, and I don't quite understand why a 2-dimensional rotation would kind of like overpower the 1-dimensional when they're both 1. 1 square equals 1. But be that as may, let's head on. Furthermore, the independent 1-dimensional nature of the relation of the electron and its positive counterpart, the positron, leads to another unique effect. As we found in our analysis of the rotations that are possible for the basic vibrating unit, the primary rotation of atoms and particles is 2-dimensional. The simplest primary rotation has a 1-unit magnetic, or 2-dimensional, displacement, a unit deviation from unit speed, the condition of rest in the physical universe. So that's unit speed is the condition of rest. That's the progression. So this magnetic rotation, this two-dimensional displacement, is a unit deviation from the progression. So this is one step toward rolling back that progression. The electric, and so is that rotational base. The rotational base is first you get that photon, the vibration, and then you get that rotation of the photon, and the two combine he calls the rotational base. And so those are kind of like neutralizing that outward motion of the progression and then getting ready to actually reel it in and move it back toward gravitation, toward moving it inward as opposed to outward. So the rotational base is kind of where it's not outward or inward, I think. Okay, I think that's right. Now this is complicated because Dr. Perret, in many of his revisions of this, has kind of overhauled this whole system, not really calling it wrong, but just calling it a little bit more complicated than Perret is always kind of looking for more intuitive ways of doing these things. And so his rotational base is kind of like built right into the system, whereas Larson's is a little bit more contrived, it seems. So I've been studying some of the Perret today earlier, and so now my mind is a little bit clouded about what's what. Okay, the electric one-dimensional rotation we found is not a primary rotation, but merely one that modifies a previously existing two-dimensional rotation. Addition of the 1 unit space displacement of the electron rotation to an existing effective two-dimensional rotation increases the total scalar speed of that rotation. But the one-dimensional rotation of the independent electron does not modify an effective speed. It modifies unit speed, because the electron is independent. It modifies unit speed, which is 0 from the effective standpoint. And again, that's the progression. The speed displacement of the independent electron, its only effective component, therefore modifies only the effective space, not the speed. Thus, the electron is essentially nothing more than a rotating unit of space. This is a concept that is rather difficult for most of us when it is first encountered. The electron as a rotating unit of space, because it conflicts with the idea of the nature of space that we have gained from a long continued but uncritical examination of our surroundings. However, the history of science is full of instances where it has been found necessary to recognize that a familiar and apparently unique phenomena is merely one member of a general class, all members of which have the same physical significance. Energy is a good example. To the investigators who were laying the foundation of modern science in the Middle Ages, the property that moving bodies possess by reason of their motion, impetus to those investigators, is kinetic energy to us, was something of a unique nature. The idea that a motionless stick of wood contained the equivalent of this impetus because of its chemical composition was as foreign to them as the concept of a rotating unit of space is to most individuals today. But the discovery that kinetic energy is only one form of energy in general opened the door to a major advance in physical understanding. Similarly, the finding that space or that the space of our ordinary experience, extension space, as we are calling it in this work, is merely one manifestation of space in general, opens the door to an understanding of many aspects of the physical universe, including the phenomena connected with the movement of electrons in matter. In the universe of motion, the universe whose details we are developing in this work, and whose identity with the observed physical universe we are demonstrating as we go along, space enters into physical phenomena only as a component of motion. And the specific nature of that space is, for most purposes, irrelevant, just as the particular kind of energy that enters into a physical process usually has no relevance to the outcome of the process. The status of the electron as a rotating unit of space therefore gives it a very special role in the physical activity of the universe. It should be noted at this time that the electron that we are now discussing carries no charge. Okay, that's very key. You have to keep in mind that this is an uncharged electron, of which there is no such thing in in mainstream legacy science. So the electron that we are now discussing carries no charge. It is a combination of two motions, a basic vibration and a rotation of the vibrating unit. As we will see later, an electric charge is an additional motion that may be superimposed on this two-component combination. The behavior of charged electrons will be considered after some further groundwork has been laid. For the present, we are concerned only with the uncharged electrons. Okay, so we'll get to the charged electrons later, but this is such a thing as an uncharged electron. I'm sorry about this noise in the background. Something's up with this heater. And I'm also just waiting for the power to go out because there's an electrical storm coming or here. So let's keep our fingers crossed. As a unit of space, the uncharged electron cannot move through extension space, since the relation of space to space does not constitute motion. The only thing that constitutes motion is the relationship between space and time. So it can move through time, but it can't move through space as an electron, because the electron is a unit of space. It's a rotating unit of space. So it cannot move through space because space to space is not motion. Space to time is motion. So it can move through time, but not space. But under appropriate conditions, it can move through ordinary matter, because matter is mostly made out of time. Inasmuch as this matter is a combination of motions with a net positive or time displacement, and the relation of space to time does constitute motion. The present-day view of the motion of electrons in solid matter is that they move through the spaces between the atoms. The resistance to the electron flow is then considered to be analogous to friction. Our finding is that the electrons, the units of space, exist in the matter and move through that matter in the same manner as the movement of matter through extension space. So there's the analogy that he's giving, and this is basically the reciprocal analogy. So you have a piece of matter, a chunk of matter, an aggregate of matter, and you throw it through space. That's the motion of matter through space, or basically time through space. And the relationship of time to space is motion. So we've got, that's the analogy of the electron moving through matter. So the electron moves through matter in the same way that matter moves through extension space, or, three-dimensional space. Okay. The motion of the electrons is negative with respect to the net motion of material objects. This is illustrated in the following diagram, which I don't have access to here. He goes over the diagram in case you want to refer to one of Larson's books and take a look, but line X in the diagram is a representation of a scalar magnitude of extension space, as it appears in the conventional reference system. Line A shows the effect of a unit of motion of a material object M through that space. The object that was originally coincident with spatial unit 1 is now coincident with spatial unit 2. Line B shows what happens if the original motion of object M is followed by a unit of electron motion. Just as object M moved through space X in line A, so space X, the electrons, moves through object M in line B. In one unit of motion, line A, object M advances from spatial unit 1 to spatial unit 2. In the following unit of the inverse type of motion, time line B, the numbered spatial locations advance 1 unit relative to object M. This brings M back into coincidence with the spatial unit 1. The same result that would have followed if object M had moved backwards in the absence of any electron movement. I don't believe that it would have helped me to have that picture in front of me. That kind of a description is just something that I just have no chance of following, other than like reading it over and over and over and over again. So if you can follow that type of approach, good on you. Please help me, because that I can bang my head against that for all day long and not get anything out of it. Okay, thus the movement of space, or electrons, through matter is equivalent to a negative movement of matter through space. It follows that the voltage differential that causes the electron motion and the stress in any substance that absorbs the motion are likewise negative. And here again, I think Larson pulls in this this thing about the voltage differential and the stress, and I don't think he needs that there. He's probably going to build on it later, but it kind of de-emphasizes the main point that he's getting at, which is that the motion of an electron through space is really through time or through matter is the negative, or really the reciprocal of the motion of matter moving through space. They're the same concept, but one is the negative of the other. Okay, directional movement of electrons through matter will be identified as electric current. Okay, so electric current is this motion the motion of units of space or electrons through matter. Well, and this is uncharged electrons. So the electric current is uncharged. Directional movement of electrons through matter will be identified as electric current if the atoms of the matter through which the current passes are effectively at rest relative to the structure of the solid aggregate as a whole. Uniform motion of the electrons, or space, through matter has the same general properties as motion of matter through space. It follows Newton's first law of motion and can continue indefinitely without addition of energy. This situation exists in the phenomenon known as superconductivity that has been observed experimentally in many substances at very low temperatures. But where the atoms of a material aggregate are in effective motion thermally, meaning they have thermal motion, which we kind of just went over in the last several chapters. And a thermal motion is an outward motion, says an effective motion thermally, movement of electrons through the matter adds to the spatial component of the thermal motion, that is, increases the speed and thereby imparts heat to the moving atoms. Okay, so that would be electrical resistance, I believe. And so that is why the electron motion cannot exist forever unless there's like no heat in the atom. Then it can be superconductive. If there isn't any type of heat motion to interfere, thermal motion to interfere with the movement of space through time or space through matter, because the heat is a spatial, and so that creates that friction, or that he says increases the speed and therefore imparts energy or heat to the moving atoms. The magnitude, it looks like we're pretty much out of time here. So we will take over here in chapter 9 on electric current tomorrow. And thanks for tuning in today, and have a great day.